Okay, I've been getting a lot of exercise at the microphone. So far, most of the discussion or implications of the discussion about regulation have pointed to the federal agencies, some of whom have been represented already, some of whom we hear from tomorrow. Early on in the meeting, there was reference to the local regulatory efforts in the city of Berkeley and the discussions in the city of Cambridge. And I know that in Tempe at ASU, when we held a sort of mock city council meeting after those events with nanoscience and engineering students, this topic came up. Do we need to pay attention either from the occupational safety and health side or from some other perspective about local regulatory issues, nanoproduction, and first responders? Because I know, for example, that in laboratories they have to make available all sorts of information about the materials that are there in the case of fire or other hazard locally.
I have experience with 3 local authorities in this respect. One is the Texas Commission on Environmental Quality. The other one is the South Dakota Department of Environment and Natural Resources. And the third one is the New Hampshire Department of Environmental Services. Between those 3, I have gotten extremely different responses to my inquiries about what I should do or how I should work with them. I believe that the TCEQ's response, and I'm not trying to say anything bad about Texas, because I never say anything bad about Texas, but their response was, if you don't do anything bad, then we're not going to come get you. And I am not making that up. The South Dakota Department literally didn't know what to do with this. And I had to sort of step them through. They would ask me, what is wrong with this stuff, or what do you think is dangerous? And then I worked with someone there and I prepared a plan for that. New Hampshire, great people, very open, and again, I anticipate that's what it's going to be like there. There's, I would say, not willful ignorance, but I'm just saying this is something that's beyond their ken of responsibility or knowledge.
The sensitivities really change from jurisdiction to jurisdiction and culture to culture, because like Texas is very different from California, and our history with this is a good example of regulating environmental law is very poor in one respect and very advanced in other areas. Most people don't realize that we regulated public city water quality probably 30, 40, maybe 50 years before the EPA ever started it. And we had these signs on our cities that when you drove in, it was a state-mandated sign that said superior public water system, acceptable public water system. So we used kind of the scarlet letter approach for regulation, very different from the punish you kind of regulation. But when I've been involved with new materials, it's often difficult to figure out which state agency to even ask the question to. So usually I bounce it through the state health department, because they can usually pierce and talk to whoever they need to, because if it is at all a public health hazard, then you can usually get the answers fairly quickly.
And on more of a national scale, we, NIOSH, have been asked by several organizations and associations that represent emergency responders, both medical or chemical, and from the federal groups such as Homeland Security on down to state agencies. And they're all the same kinds of questions. What should we be concerned about, and is our current protective scheme adequate? So we have actually done some testing on some response gear, protective clothing and respirators, and that was a key piece of research NIOSH did almost 5 years ago. And we give them the basic recommendation that you're dealing with a small particulate in most cases, and you already know how to deal with a lot of that. Here's what's different, if anything, about these materials. Here's what we know about the protection factors for your clothing, your turnout gear, your respirator, your gloves. But at the same time, don't forget that if you do respond to the company that's making carbon nanotubes or nano TiO2, whatever it might be, you're also going to encounter acids, bases, high pressure, high energy, high temperature, and so it's a variety. It's not just the singularity of that nanomaterial that you should be concerned with. And I also remind a lot of researchers about that. When I get a call from someone who says, I'm the health and safety officer for a major university, I have a researcher using carbon nanotubes, what respirator should they wear? I usually back them up and say, what makes you think you need a respirator, and let's work through that first. So we've had similar discussions with the emergency responder organizations.
And I just want to parrot some of this. The hazards that are often right in front of your face are often the really dangerous ones. And I've been involved in cases where I've had this exact thing happen, like the acid spaces, that hydrofluoric acid, for instance, that people don't realize is very dangerous, and they're using it all the time, and they don't realize how dangerous it is.
And yet, well, I'm asking you, is there some progress in developing respiratory equipment that workers are more likely to use and, that can really work in the expected ways?
Yeah, a couple quick ways to answer that. Protective equipment is always your second choice. We always want to see some way of controlling it through either an engineering or a materials basis first. The lab fume hood being a good example. I'd rather see someone learn how to use their lab fume hood or their low-flow containment device or their biosafety cabinet before asking the question, what respirator should I use? Now, an awful lot of work is going on, and NIOSH does have a respiratory protection research program, just constantly trying to work with the respirator manufacturers. What makes user acceptance higher? We've got some awful good respiratory protection and other protective equipment available to our workforce in this country. It's a matter of making the connection between the worker who needs it and the availability of that equipment and the training and the selection of it. So it's the daily question. What can we do to make this more acceptable, wearable to the worker? And that doesn't mean that they aren't today. There's a lot of good equipment available.
Well, there is a social use question in there as well, because some workers are in the cultural milieu where the use of the material of the protective equipment is discouraged. So.
And there's also the regulatory aspects of it. There are certain exposure situations, certain jobs, depending on the material you are handling, where the respiratory protection is mandated. It's a regulatory requirement, and respiratory protection implementation or putting a respiratory protection program in place does follow a very rigorous, prescribed, legal menu of activities that you have to follow. But there are also situations where a worker may elect to wear one, and you still have to work with that person and say, we're not sure you really need this, or here's evidence or data that demonstrates that you don't need this. We're not above some threshold, or in cases of nanomaterials, we don't know what the thresholds are. But we've done evaluations, your control procedures work, we don't measure the contaminant, whatever it might be. In your workspace anywhere, you really don't need it. But if you still want it, we'll work with you to pick the right one, and you'll wear it properly, and you'll act as if you had to wear it. So you don't want someone just grabbing a respirator and just putting it on just because they think it's a good idea.
Also, business, just very quickly, has an issue with this, which is NIOSH can, and I look to NIOSH for information, but the EPA, in a consent order, will specifically describe and prescribe certain types of PPE. And Chuck's smiling because we've had this conversation. The EPA can mandate this, but I don't know what level of expertise they have. They have the authority to do this, but whether it's the right thing to do.
Yeah, we're crossing some regulatory fences here, because OSHA is recognized as the primary workplace regulatory agency. However, EPA, in issuing orders on new manufacturing or significant new use rules orders on either end of that, can issue guidance for workplace protection, including prescribing protective equipment that workers should wear under situations that they refer to as reasonably likely to be exposed. So you have to keep your eye on several different agencies when it comes to who's going to require you to wear protective equipment. NIOSH's regulatory authority in all of this is, in fact, it's the only regulatory authority we have, and that is to test and certify the performance of the respirator. Everything else NIOSH does is research and recommendations.
Universities are sort of on the front lines of exposure, and it's tricky because nanomaterials are used or made in such a wide variety of labs across the university. And I think a lot of the equipment we have is adequate for dealing with them as the same equipment we'd use for chemicals, but these sort of balance enclosures, these low flow devices for dry transfer, those would be very useful. Would NIOSH recommend that most academic labs dealing with nanomaterials have access to or have their own, HEPA filtered, low flow, pharmaceutical type balance enclosure? Is that really realistic in terms of cost?
Well, there's always the cost issue. There's also the project application and flexibility issue, too. Having once had global responsibility for a bunch of research labs all around the world that looked a whole lot like academia but were part of a corporate culture, I kind of feel your pain in this. But then we also had the advantage of being a corporate organization. When looking at what kind of control device do I need, and I need to build that into my project plan or my budget for the next 3 or 5 years, which sounds better? I'll use a brand name, doesn't constitute endorsement, but Flow Sciences, for example. That's one of 4 or 5 types of low flow devices you can buy. A 6-foot wide Flow Sciences device that's either plumbed into your central exhaust system or has a self-contained HEPA filter might cost about somewhere between $6,000 and $12,000, depending on how you depreciate it. A standard 6-foot laboratory fume hood, anybody know what the current price is? And I've kind of lost track on it. It's probably somewhere between $30,000 and $40,000 to install, and another $1,000 a year minimum to operate, probably more than that. So, I mean, there's actually some economies in looking at these flexible containment devices that can be used in a variety of projects and moved from area to area as they're needed. And there's a lot of validation data that they are effective in their containment.
Yeah, we just don't have them now. And we have 2 labs, mine and someone else's, where we beta testing those for one of the companies. But otherwise, people use nanomaterials all the time. These aren't necessarily dedicated nanosynthesis labs.
Right.
They're just a lab where you can buy, nanomaterials from Aldrich, and they come in bottles,
Sure.
and they're open and used, and it happens all across the university, and almost never in one of those balance enclosures. I've seen the videos that the pharmaceutical industry takes where you're weighing something, it seems fine, but then they show the whole thing under fluorescent light, and you can see the active particles sticking on your mustache and such.
Yeah.
But we don't. It's the Wild West at the university, pretty much,
Just as long as you just ask the question, that's good.
Well, if there's someone who probably needs a little bit of stroking and a cookie thrown under the door every now and then, it's your campus health and safety officer. I mean, they really can help. The other thing that would be helpful is bring the PIs to sessions like this.
Yeah.
we could take a spontaneous tour of Notre Dame. Kathleen, how about that? But I suspect we wouldn't find many of those.
We'd find lots of fun things. We'd probably find safety glasses hanging off the gas valves on the sides of the fume hoods. We'd probably find GCs inside of fume hoods. The fume hood it's a mixed blessing because it's the universal control device, or at least perceived as that for laboratories. But it is the most, as far as control devices, it is so easy to upset and violate and destroy the containment that they're designed for. So it's a mixed blessing.
This is a question directed especially at Mark Banish, since we didn't get a chance to ask you questions right after your talk. Hopefully it's okay in this general discussion. I was curious about some issues related to business ethics. I think it's really neat, a lot of the things you described. And one issue that comes up in business ethics discussions is balancing responsibilities to make money for the shareholders, as opposed to dealing with labor and environmental issues and safety issues and things like that. And both sort of last night and in part of your discussion today, I thought it was really nice. You pointed out that over the long run, it makes sense from the perspective of the shareholders to be doing a good job with these issues. But I was just curious if you can think of any examples in your experience where there wasn't such a nice convergence, and where your company's commitment to these ethical concerns about environmental issues and labor issues might have clashed in certain respects or been a challenge from the perspective of making money. And then I'm sort of interested in the question of sort of how you're able to operate that way as a company. Do you think it's easier right now? You're so far kind of ahead of the game relative to competitors that you can you don't have people trying to undercut you with less excellent practices. I'd just be curious to hear your thoughts on these issues.
Well, that's a very interesting question because, and to do service to my board, everyone who came on board as investors at NanoComp has a clear feeling about social justice and treating the environment properly. So we're blessed in that respect with having a very good board. Matter of fact, I don't know how many corporate boards where the safety officer actually presents something, but I actually do. And so it's part of our culture from all, I don't know if it's from the New England sort of environment or whatever it is, but that's part of it. I have unfortunately experienced companies where the work ethic and the culture and the attention to safety are not as good. And I have seen in those types of environments where you have a different sort of corporate culture. The CEO tends to be the lone investor. He may or may not have the technical competence to view what's going on, and he is completely focused on his ROI and just focused on getting it out the door. And under those, it's like the old movie producer who used to walk around the set screaming, "Dollar, dollar, dollar." That's what it's like. And a lot of pressure for people to succeed, to push the product, push things forward, to make shortcuts. And it's just a typical, any type of environment like that you run across in business. I have seen that. Unfortunately, I have seen that in nanomaterials.
Chuck, you mentioned this NIOSH intelligence bulletin for TiO2 coming out any day now, and where the fine TiO2 had a value of 1.5 milligram per meter cube, and the ultrafine 0.2 milligram per meter cube. That's about a factor of 8, which is right the difference between the ultrafine P25 TiO2 and the larger one at a factor of 8. And I think that was also the basis when Aline Kümpel made these derivations. The question, though, is, so if you have, where do you draw the line between the fine and ultrafine? Think of Pratim's 2 nanometer TiO2 that you make that should have a much, much lower value than 200 microgram per meter cube. So how do you deal with that?
Not very well. No, that was a smart answer. I think we have to look at that, and as we get more information and more data, it's going to be a combination of looking at the data that are available, looking at exposure scenarios, using the risk management models that Eileen and the other risk assessors used. And for those who haven't been following this document these last 5 years or so, we actually normalized on surface area as the dose metric for doing the risk assessment, but had to convert back to mass because that's what everybody can do and that's what they're used to doing. But Gunther brings a good issue up. What now, and since this was based in the scheme of nanomaterials, a larger nanoparticle, how do you deal with one that's extremely small and much smaller and then shows different biological characteristics? We didn't have data on that particle at this time, and so as we go forward looking at any kind of updates and reviews of whatever we put out, whether it's TiO2 or carbon nanotubes or anything, I think as a research institute, it's our responsibility to look at that and evaluate it and issue new information. It might, yeah, it makes it very complex. But one of the things that's I think important to keep out in front of us is when you make the decision to put a good practice in place, and my preference would be some type of a containment or engineering control with good work practices, followed by protective equipment. Once you do that, it's very easy to control so many of these materials. When you turn your control device on, it doesn't have a sliding scale. You suddenly go from, yes, I'm finding a lot of your material, to I hardly find any, if any of your material, if any at all. So I preach to people that good engineering controls are a great investment because they work on a spectrum of materials. And there isn't a dial up on the control that says, well, today I'm going to control to 5 milligrams, tomorrow I'm going to control to 2, and maybe if NIOSH comes out with some more data, I'll control to 1.5. You kind of design for optimal containment.
Sure, no, I agree with that. That's a simple thing to do, but it may give a false sense of safety when you have these levels, these exposure levels, if they would become
Yeah.
In the aftermath of the collapse of the World Trade Centers, many hundreds of people breathed in a lot of dust of all types and other things. And in the months that followed, a lot of people, I think, chose not to wear masks as they're uncomfortable and so forth. And that's, I'm sure, a big, long topic of discussion. But what kind of pressures were put on the workers by their employers to wear the masks and to, but I don't know if that's an appropriate question, but are there nanotechnological implications to that situation that could be a broader message to the general public and, you know, as an object lesson, hey, take this stuff seriously?
I want to address both that question and not precisely the World Trade Center, but the question that the speaker two minutes ago, the ethical question of corporate practice. I have directly been put in a position by several companies where they essentially asked me to render an opinion about certain processes that were I considered unsafe, where they didn't want that in writing. I actually happen to be fortunate coming from Texas because Texas has an occupational illness reporting statute that when somebody imposes on me a contract to review a work site, if I find something hazardous, I can actually pierce that contract and report it to the health department. Other states don't have that reporting statute. And it's interesting, but now that I've had that happen to me multiple times, I mentioned it up front, and it's amazing the number of people that are honest. They'll say, oh, yes, we'll take you on. That doesn't bother us. But there's also a chunk of people that recoil very quickly. And so from the point of view of what do we do from a public policy when we have workers that are exposed to this, I've been in that situation as well with responders, especially for bloodborne pathogens, because there's a lot of question about, in certain situations, what you should do. And especially since our vaccines are so effective, we've gotten rid of like hepatitis B, that's the real infectious agent, but there's some people that still feel uncomfortable about this. And again, the interesting thing is the counties and cities will put very much pressure on you to render an opinion a certain way that I don't quite know how to handle it, but I usually just go back to the science and try to render the opinion the best I can. But when you get in these situations, the pressures come from all sorts of different directions that are very hard to predict. And it's also even more irritating because then you're put in a situation where the science is unknown and you're really trying to do the best you can. So, and I'm not quite sure if that answered your question directly with the World Trade Center, but I hope it got close.
I think the biggest thing with World Trade Center is there were multiple jurisdictions involved. It was a traumatic, chaotic experience. I think if NIOSH would have had its preference, everyone would have stayed in their respirators through the entire recovery process. I think we're learning now that just the gross acute exposure that occurred to just this unbelievable mix of ultrafine materials that came out of that plume, I think we're seeing the health consequence of that now. And respiratory protection, in hindsight, would have been a very good thing for everybody if it were available. That's another with something like that. It's also to the logistical issues. So that's why you can see that when you have the opportunity for a managed and controlled approach, and you ask yourself the question, is respiratory protection worth considering? You can go through a pretty good logic profile on trying to answer that question. But World Trade Center was a disaster in many ways. But I think one of the real difficulties was because NIOSH was part of the response. Was just the multiple jurisdictions and trying to understand really who had overall jurisdiction.
Two comments perhaps that will provoke some response. The first one, as a European, I have this kind of stereotype about Americans that they mostly want the government off their backs and so forth and so on. And this, in light of this stereotype, is actually kind of interesting that in our discussions so far, there has been really hardly any mention, if any, of voluntary codes of conduct, codes of good practice that are adopted by companies, which is a major topic of discussion in Europe, and many companies have these, and of course also use them in their advertisement and so forth and so on. And correlated to that, the idea of giving out, let's say, certificates of good practice as a kind of seal of approval that companies can apply for. So these kind of instruments are very important in Europe, and of course debated too whether they're appropriate or not. And I haven't heard this here, so this might just be an interesting point for our discussions. The second point concerns this whole question about who are we doing this EHS research for. Right now, we are now focusing very much on those people who are most exposed, the people in the laboratories and at the workplace. But at the same time, you might say the laboratory and the workplace are sites where one could try to limit exposure. I mean, at least even if we don't know much about risk assessment, we do, as long as we know about potential hazard, we can sort of adopt all kinds of proactive strategies of reducing exposure. How does any of this transfer now to protecting the consumer or protecting the environment?
I'd like to respond to that first question, and that is that my company is developing that best practice. As a matter of fact, I have draft articles on IPC which have titles, carbon nanotubes, how do we know what's in this stuff, and detection and characterization of airborne carbon nanotubes. And this is going to be part of our website. We're redesigning our website so this information will be available to the public. My goal from working with people like Chuck and everyone else is to make this information go out there, to be completely transparent, and to put this stuff forth. So our view of what would be a good practice is to be perfectly clear with how we measure things, how we do things, how we can recommend that to other people, and to solicit feedback and to change things. So in terms of us, we're going to be very open about it.
You're not suggesting it as a kind of substitute for regulation.
No.
Discussed in Europe. I mean, that this is one way to implement safety standards.
Mm-hmm. I'm sorry.
I wanted to comment on the creeds and codes aspects that are voluntary, because in occupational medicine especially, the physicians are scattered all over the companies and government and everywhere. And it's interesting, in the last 10 years, I and many of the physicians have been pushing for a code of conduct, a code of ethical conduct, because you get in positions where there's no clear line what to do, and the physicians will go back. This is happening in my professional society, where we establish this code so that when we get pushed into these gray areas that we can have something to fall back on. We do consider it very important, because many times the regulation is just always going to be unregulatable because it's gray, and then people come to us and say, well, what would you do? And so we have to fall back and try to come together, and that's the best thing we've done so far.
Ralph.
On the voluntary code, there's been an interesting effort by DuPont in conjunction with the Environmental Defense Fund on a code of best practice, et cetera, that has gotten a lot of attention. And the dynamic oversight model that we talked about the first day is designed to have a spectrum from voluntary codes, information, et cetera. There have been some efforts there. EPA had a voluntary nano disclosure program of, I think, marginal success.
Yes, we were one of the companies that actually participated.
You were one of the 9.
One of the 9. Yeah. I think part of the political reality is I think there's a certain distrust of voluntary codes that's in the United States.
And I think one thing that I experienced personally in my former employment with the Procter & Gamble company is that codes of practice are fairly standard in many larger companies, because it does two things. It protects their assets and it promotes their business, and it gives them a competitive edge. If they can handle a hazardous material better than their competitor, then that's a good thing. But I think they're beginning to realize that those codes of practice can benefit the entire industry, not just their own company or their own segment of it. So there is some thinking that open sharing of some of the better parts of these different practice codes or best practices, whatever you want to call them, is beneficial. I think a lot of it's coming because of the drivers in Europe in looking at codes of practice. Is it intended to replace regulation? No, I don't think so. I think it's looked at as that gray area or that soft law approach until there's hard law in place.
So this may be somewhat related. I've learned a lot over the last 2 days, and maybe I've missed this. I was out of, but the one thing that I haven't heard much discussion about is disposal. So, I mean, we use a lot of radioisotopes in my lab, and we have to know exactly where it's all going. Mm-hmm. And I've really heard nothing about disposal out of research labs, disposal out of industry. And if you want to comment on that.
Well, I can comment on it because I have to deal with it every day. One of the things that the EPA has asked us is to track stuff. One of the reasons we're becoming ISO 9001 compliant is because we'll have a quality system that will force us to have an auditable process for tracking. Right now, we have a work order process. I can tell you on what day, what sheet was made on what system. I can tell you how much of that sheet went into what order, and I can tell you how much of it went into the waste stream. And I have an audited from our hazardous waste disposal service. I have an audited list, and I can tell you how much actually did go into the waste stream. They can confirm it. Now, this is right now, I'll be frank, expensive. I mean, you're talking $500 or so of a barrel to throw things out. And right now, I'm looking to regulation for clarification on that. But it goes into, it's treated as solids hazardous waste, and it's treated as carbonaceous waste, and it's sent to an incinerator. And it's burned at, I think, 12,000 degrees, or however hot that darn thing gets.
Is it shipped across state lines?
It is shipped across state lines. It goes, oddly enough, to Ohio.
Interesting.
Yes, it does. And
we give up Brian and we get your carbon nanotubes.
that's right. But again, we're dealing with, there's classifications and EPA and hazards, and I have a license from the state of New Hampshire, and I have an EPA number for all this. And in this point, we did. We just said, look, we don't know what this is, so let's treat it like we would treat any other hazardous waste.
Yeah. And we certainly don't make we don't make recommendations on how a waste should be handled. It's out of our purview, though we get a lot of good information and we can pass along what other people are doing. But we certainly make sure that the company has included the task of handling the waste as a part of their overall health and safety program.
Well, do you ever envision this getting to the point where you're going to have the same problems that we have with radiological waste, and no one wants to accept it?
It's interesting you mentioned radiological waste, because they're putting in a new low-level radiological waste site in western Texas, and the interesting thing about radiation is it's so easy and precise to measure that you can trace it. The question is, are these other devices that we're designing actually going to be that measurable? And I can't answer that. If it's not going to be very measurable, then I can't see how we're going to have to trace it till infinity, but that's a philosophical distinction.
I'm just wondering more, is there a looming problem where you're not going to find a place to put it?
That's probably a political question as well, because like the low-level radioactive waste, the states have actually started fighting each other to prevent other states' low-level radioactive waste to come in, and it's an interesting area. It could easily slop over into the things. That's why I asked him, does it cross state lines? It's not a benign thing. I mean, the next question would be, does it go on a train, or is it in a semi?
It's a truck.
It's a truck. See, so that's, a lot of people don't realize that these things go around right next to them on the highway or on this rail. It's a very interesting question.
There's also stuff maybe in somebody's body armor or their backpack, so what happens to this stuff then?
You also get into this concept of de minimis. What is a de minimis amount? Because if it's below a certain amount, you get out into, so if little Joe Blow the plumber uses this, are they supposed to register with the EPA?
And EPA is just on the front end of looking at fate and transport of any nano-based material.
I would like to propose that we thank our speakers and take the rest of our questions to dinner.
That's a great question. We have to